Okay, we're doing just a little review here with some integrals. First one we're looking at is arc length. So we've got a skateboard, consists of this straight ramp here, which is our first equation. Our second one is this parabolic section, and then another straight line given with this piecewise function. Which of the following expressions gives the length of the track from 0 to 14? So the first thing is that I'm just going to look at these straight components first, because if you look at all the answers, there's this plus a complicated section after that. And so what my gut reaction says is, oh, they were just taking those first ones as nice straight distance points. So the first one is from 0, 6 to 4, 3. So that's a 3 by 4 triangle. So we've got 5, and then this part is 2. So that's how you get this 7 component that we see here in both of these. Then the next thing is just to find the parabolic section. And if you remember from arc length, that is 1 plus dy dx squared, because it's coming from the distance formula, dx from a to b. And so then if this is the only one we're worried about, we just need to ask ourselves, what's the derivative here? And so we can use our chain rules. The 1 is a constant, so it drops away. So then it's 1/8 2 times x minus 8, like that. And that's the derivative. Then simplify it. We've got 1 over 4 x minus 8 is dy dx. So then when we plug that into our integral, we get 1 plus that squared, which is how we end up with the 16 here, and the x minus 8 squared, which is how you get D is the correct answer. Again, let me know if you've got questions on that. The other one was a series review. For what values of P is the series conditionally convergent? So what that means, again, is that it only passes the alternating series, but it fails the other series test, like the ratio test. So hopefully what a lot of you did is that you recognize that, oh, this plus 2 isn't really doing anything. And so the series that we're actually really talking about is the alternating series of n over n to the p, which these cancel out, the n's here, and we end up with n p minus 1 like this. So we know that it's going to be absolutely convergent if the power in this power series, p minus 1, is less than 1, or in this case p is, turn that around. The power is greater than 1, which means that p is greater than 2 is absolutely convergent. So therefore, with conditionally convergent, we're looking at the inverse of that. So we now know that this is one of the upper bounds, this is one of the bounds, because here's where it's going to be absolutely convergent. So that means that P has to be less than to be conditionally, but we also still need to have it in the denominator, because otherwise it's going to fail the alternating series test, which, if you remember, states that consecutive terms have to be less than. So we also still want to keep this in the denominator, which means that P minus 1 can't equal a negative number. So therefore, P minus 1 has to be greater than 0, which means that P has to be greater than 1. So main thing here is just remembering conditionally convergent versus absolutely, and then using your two different tests. Let me know if you have any questions, or if there's anything I can help with by email, on Google Classroom, or on Zoom.